Installing a 2-position meter with a 100 amp breaker and a 200 amp breaker in a 200 amp meter cabinet is generally permissible. This configuration is frequently used when upgrading an existing 100 amp service to a 200 amp service. The primary function of the 200 amp breaker is to safeguard the service conductors, while the 100 amp breaker is responsible for protecting the branch circuit conductors that supply the panel located on the second floor. However, a critical consideration is to ensure that the total load connected to the 200 amp breaker does not exceed its rated capacity of 200 amps. If the anticipated load surpasses 200 amps, it will be necessary to install a larger meter cabinet to accommodate the increased demand. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including service upgrades and breaker sizing. It is crucial to adhere to these guidelines to ensure the safety and proper functioning of the electrical system. Firstly, the service conductors must be adequately sized to handle the total load. Secondly, the overcurrent protection devices, such as breakers, must be selected based on the ampacity of the conductors they protect. Thirdly, the meter cabinet must be large enough to accommodate all the necessary equipment, including the meter, breakers, and wiring. When performing a service upgrade, it is essential to conduct a thorough load calculation to determine the total electrical demand of the building. This calculation should take into account all the connected loads, including lighting, appliances, and equipment. The calculated load will then be used to determine the appropriate size for the service conductors and overcurrent protection devices. In this specific scenario, the 200 amp breaker is intended to supply 2 panels, one on the first floor and one in the basement, while the 100 amp breaker supplies a panel on the second floor. The current load is reported to be approximately 25 amps or less on all 4 legs, which is well within the capacity of both breakers. However, it is important to consider future load growth when sizing the breakers. If there is a possibility that the load will increase significantly in the future, it may be prudent to install larger breakers to accommodate the anticipated demand. It is also important to ensure that all the wiring and equipment are properly installed and grounded. Improper installation can lead to electrical hazards such as shocks and fires. It is always recommended to consult with a qualified electrician to ensure that the electrical work is performed safely and in accordance with the NEC. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in technology and best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the NEC and to adhere to its requirements. In the 2008 NEC, which is the code edition relevant to this situation, specific articles address service entrance requirements, overcurrent protection, and panel board installations. For example, Article 230 covers service entrances, providing guidelines on conductor sizing, overcurrent protection, and grounding. Article 240 addresses overcurrent protection, specifying the requirements for fuses and circuit breakers. Article 408 covers panel boards, outlining the rules for their installation and wiring. When installing breakers in a panel board, it is crucial to ensure that they are properly seated and securely fastened. Loose connections can cause overheating and potentially lead to electrical fires. The breakers should also be labeled clearly to indicate the circuits they protect. This will make it easier to identify and troubleshoot electrical problems in the future. In addition to the NEC, local codes and regulations may also apply to electrical installations. It is important to check with the local authorities to determine the specific requirements in your area. Local codes may be more stringent than the NEC in some cases, and it is essential to comply with all applicable regulations. When upgrading an electrical service, it is also important to consider the capacity of the existing electrical system. If the existing system is not capable of handling the increased load, it may be necessary to upgrade other components, such as the service entrance cable, the meter, and the grounding system. The service entrance cable is the cable that connects the utility company's transformer to the building's electrical panel. It must be sized appropriately to handle the total load. The meter is the device that measures the amount of electricity consumed by the building. It must also be rated to handle the increased load. The grounding system is the system that provides a path for fault current to flow back to the source. It is essential for safety and must be properly installed and maintained. In summary, installing a 100 amp and a 200 amp breaker in a 200 amp meter cabinet is generally acceptable, provided that the total load does not exceed the capacity of the breakers and that all applicable codes and regulations are followed. It is crucial to perform a thorough load calculation, select the appropriate breakers, and ensure that all wiring and equipment are properly installed and grounded. Consulting with a qualified electrician is always recommended to ensure that the electrical work is performed safely and in accordance with the NEC. Consider NEC Article 220.87, which is related to optional calculation for dwelling unit. This section allows using the actual recorded maximum demand to determine the new service size. The 25 amp load, if accurate and reflective of the true peak demand, strengthens the case for the proposed installation. However, future load considerations are paramount. Remember to verify the short circuit current rating of the panel board and ensure that the breakers used have an interrupting rating sufficient to handle the available fault current at the service. This is a critical safety consideration. If the available fault current exceeds the breaker's interrupting rating, a catastrophic failure can occur during a short circuit. The electrical inspector will verify this during the inspection process. Also, when dealing with multiple dwelling units served by a single service, be sure to comply with NEC Article 230.71 regarding the number of service disconnecting means. This section limits the number of disconnects to 6. The described setup with 2 meters, each having a main breaker, would fall under this rule. Lastly, it's recommended to take pictures of the entire process as you go. This will allow you to better understand and remember what you have done and have proof of your work. Ensure that the meter cabinet is properly grounded according to NEC 250. This typically involves connecting a grounding electrode conductor from the cabinet to a grounding electrode, such as a ground rod or a water pipe. Proper grounding is essential for safety as it provides a path for fault current to flow back to the source, minimizing the risk of electric shock. Also consider that the utility company will have its own set of requirements for meter installations. Contact the local utility company to confirm their specific requirements before starting any work. They may have restrictions on the type of meter cabinet that can be used, the location of the meter, and the grounding requirements. Failure to comply with the utility company's requirements can result in the installation being rejected. Furthermore, when running conductors, pay attention to conduit fill requirements as specified in Chapter 9 of the NEC. Do not overcrowd conduits, as this can lead to overheating and insulation damage. Use the appropriate conduit size for the number and size of conductors being installed. Be mindful of voltage drop, especially over long distances. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. Use larger conductors to minimize voltage drop, particularly for circuits with high current demands. Finally, after completing the installation, thoroughly test all circuits to ensure they are working properly. Use a multimeter to verify voltages and currents. Check for any loose connections or other potential problems. It is always best to catch any issues early on before they can cause more serious problems. The neutral and grounding connections within the panel boards need to be meticulously examined. Make sure that the neutral conductor is properly connected to the neutral busbar and the grounding conductor is connected to the grounding busbar. Do not bond the neutral and grounding busbars together in a sub-panel. This should only occur at the main service panel. Also consider arc fault circuit interrupters or RF size. These are required by the NEC in many locations of the home, especially bedrooms. Ensure you are up to date on where RF size are required to enhance safety against electrical fires. Furthermore, ground fault circuit interrupters or GFCIs are critical for locations where electrical outlets are near water, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electric shock by quickly cutting off power when a ground fault is detected. Using torque screwdrivers and wrenches for making connections is also essential. Properly torqued connections ensure secure electrical contacts and prevent overheating or loose connections that could lead to failures or hazards. The 200 amp breaker should be sized according to the ampacity of the service entrance conductors. The service entrance conductors must be sized to carry the calculated load, as determined by NEC Article 220. The 100 amp breaker should be sized according to the ampacity of the conductors feeding the subpanel on the second floor. The conductors feeding the subpanel must be sized to carry the calculated load of the subpanel. Ensure that the panel boards are adequately sized to accommodate all the breakers required for the circuits they serve. Consider future expansion when determining the size of the panel boards. It's also important to label each circuit breaker clearly, indicating what it controls. This will make it easier to identify and troubleshoot circuits in the future. Use the circuit directory to document the circuits and their corresponding labels. When working with electrical systems, always prioritize safety. Wear appropriate personal protective equipment, such as safety glasses and gloves. To energize circuits before working on them whenever possible. If you must work on live circuits, use extreme caution and follow all safety procedures. Remember to use properly rated tools for the job. Using the wrong tools can damage equipment or cause injury. For example, use insulated tools when working on electrical circuits. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician. Electrical work can be dangerous and should only be performed by those who are properly trained and experienced. Also, make sure to keep a copy of the electrical permit and inspection report for your records. This will be helpful if you ever need to refer back to the work that was done. The electrical inspector will verify that the installation complies with all applicable codes and regulations. If the installation does not meet the requirements, the inspector will issue a notice of violation. You will then need to correct the deficiencies and have the installation re-inspected. It is always best to address any issues proactively and work with the electrical inspector to ensure that the installation is safe and compliant. Remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to ensure that your work is always in compliance. Consider attending continuing education courses or workshops to enhance your knowledge of electrical systems. It is good to have proper knowledge and experience to do electrical work. Remember to check with the authority having jurisdiction.